All right, now we're going to interpret that p-value, the last step of your significance test. Now, significance tests usually use a p-value, a cutoff, and that cutoff is we call alpha. And typically they use 0.05. It depends from um, study to study what you'll use. But statistically significant is when a p-value is as small or smaller than alpha. Then we say that data is statistically significant. Now, significant does not mean important. We'll learn more about that in chapter 10.3. It just means that it's not likely to happen by chance. So what are good levels for alpha? It depends what you're doing. Sometimes alpha will be 0.1 if if it's not a very important thing to be entirely accurate. Sometimes the standard is 0.05, but if you're working in a highly sensitive situation, it might be 0.01 or 0.005 or 0.001, and this would just be a very high threshold that you'd need to pass in order to prove that something is true or false. Now, the two decisions that we're going to have is we can either reject the null hypothesis or we can fail to reject the null hypothesis. Kind of like juries. Juries are you're either guilty or not guilty. We won't be able to prove that this is true. We'll just be able to say that either we reject it or we fail to reject it. Now, if you are going to state conclusions based on statistically significant data, then the significance level should be stated before the data are produced. And I'll show that. Oh, so let's go back to our previous p-values. For instance, on the paramedic example, we have a p-value of 0.01. So when we interpret that, we say since the p-value is lower than alpha equals 0.05, and we should say since the p-value of 0.013 is lower than alpha 0.05, we reject the null hypothesis. So that means we have evidence that paramedic response time reduced. So we're just having evidence. Now in this other one, this next one, we got a p-value of 0.23. That's way higher than alpha. That's way higher than alpha. So if we want to interpret here, we say since p-value is higher than alpha, let's say 0.05, we do not reject the null hypothesis. So we don't have evidence that machine and self-based are different. So that's how we interpret significance tests.